Let us start with the second part. That is 4 branches of machine learning. As you know, machine learning is a subject which deals with without explicit programming, a machine adapted to the new situations. Basically, there are 3 types of machine learning problems. Number 1, binary classification, multi-class classification, and scalar regression. See, binary is nothing but only 2, either 0, 1. Here we have a graph which represents 2 set of values. One is related with one category, second one is related with another category. It's a binary classification. If you have more than 2, that is called as multi-class classification. And the third one is scalar regression. As far as our subject is concerned, we are going to concentrate only on binary classification and multi-class classification. All these 3 instances of supervised learning, where the goal is to learn the relationship between training input and training inputs and training targets. See, basically, we have 4 broad categories of machine learning algorithms. That is supervised, unsupervised, self-supervised, reinforcement learning. There are 4 very important questions. Machine learning algorithms can be categorized into 4 categories: supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning. First one, see this. You can graphically represent these components. Start with supervised learning. Supervised learning is nothing but, before going to the in detail, see, this is called as model training. There is a prediction. We have a test data. Supervised machine learning is a branch of artificial intelligence that always concentrates on training models to make the predictions or decisions based on labeled training data. For example, we have 2 categories of training data. Number 1 is labeled, second one is unlabeled. In the case of labeled data, we have set of items. These are the labels: carrot, tomato, and bell pepper. Here there is a database down. Here we have a test data which produces, based upon your information, predictions would be carrot, bell pepper, and tomato. Whereas in the case of unsupervised, there is no labeled data at all. There is no labeled data at all. Everything is unlabeled data or input raw data. Here, there is interpretation, processing. Finally, it produces output. Unsupervised learning is a type of machine learning where the algorithm learns from unlabeled data without any predefined outputs or target variables. The difference between supervised and unsupervised means, for example, I'm giving some information in the classroom. You all are under monitoring of a particular faculty member. That is called as supervised. I am somewhere, I ask you to write something. There is no monitoring at all. It's unsupervised. So, machine learning algorithms can be divided into 4 categories. In particular, first 2 categories, supervised. Second one is unsupervised. For this, classification and regression are come under supervised learning. Clustering is come under unsupervised learning. Supervised machine learning is generally used to classify the data or to make the predictions, whereas unsupervised learning is generally used to understand the relationship within the data set, that association or mapping. First part, start with supervised learning. This is by far the most common case. It consists of learning to map input data to known targets. I told you everything is labeled. Almost all applications of deep learning which are spotlighted nowadays are belonging to supervised learning. It may be optical character recognition, OCR, optical character recognition, OCR, speech recognition, image classification, language translation, and so forth. So, supervised learning consists of optical character recognition, speech recognition, image classification, language translation. Next one. Even though we have many categories of classification and regression components exist, we have following components. Sequence generation. For example, if we have a picture, we are going to predict a caption describing it. Sequence generation can be sometimes be recreated, reformulated as a series of classification problems. It may be repeatedly predicting a word or a token in a sequence. Syntax tree prediction, given a sentence, predicts its decomposition. Division, decomposition is nothing but dividing something into partitions, into a syntax tree. Object detection, given a picture, draw a boundary box around the certain objects. Inside the picture, it can also be represented as a classification. Image segmentation, given a picture, draw a pixel level mask on a specific object. In the case of images, everything can be treated as a pixel. Pixel is nothing but picture element. Second point is unsupervised learning. I told you, in the case of supervised learning, we have a set of labels. Based upon a predefined inputs, we are going to classify, we are going to perform some kind of learning activity. Whereas unsupervised learning is concerned, this branch of a machine learning consists of finding interesting transformations of input data without help of any targets. For the purpose of data visualization, visualization is nothing but presenting the information in a better format. For that, we are using various categories of graphical tools. Data compression. Compression is nothing but reducing the size of the content without losing of data. For example, we all are using WinZip, WinRAR, etc. Or even in the case of images, audio, MP3, MP4, etc. JPEG, Joint Photographic Experts Group, MPEG, Motion Pictures Experts Group. All these components are come under compression techniques, data denoising, or to better understand the correlations present in the data at hand. Unsupervised learning is a bread and butter of data analytics, and it's often necessary step in a better understanding of a data set before attempting to solve a supervised learning problems. Whenever we have a clear target set of elements, we can have better component that is supervised. Even though we don't have any kind of targets, we can produce the outcome called unsupervised learning. Dimensionality reduction and clustering are well-known categories of unsupervised learning. See this? This is input data. These are apples called as known labels. And there is a model which produces a prediction that is called as apple. Whereas unsupervised learning is concerned, we have input data. We don't have any kind of labels. Based upon the processing, it produces the clustering. This is unsupervised. Next one is self-supervised. Generally, in the case of machine learning subject, we can have a semi-supervised. But in our deep learning concept, we have self-supervised. This is a specific instance of supervised learning. It works without human annotated labels. You can think of it's a supervised learning without any humans in the loop at all. There is no human interaction at all. There are still labels involved, but they are generated from the input data, typically using heuristic algorithm. Generally, in the case of 4th and 5th unit, we have a concept what you call autoencoders. Autoencoders are the well-known examples of self-supervised learning where the generated targets or inputs unmodified. For example, trying to predict the next frame in a video, given a past frames or the next word in a text, in a given previous words are instances of self-supervised learning. In this case, supervision comes from future input data. So the distinction between supervised, self-supervised, and supervised learning can be blurry sometimes. These three categories are more continuum without any kind of a solid borders. So self-supervised learning can be understood, reinterpreted as either supervised or unsupervised learning, depending on whether you pay attention to learning mechanism or to the context of its applications. See, we are going to perform, we have a set of elements, self-supervised learning. We are going to organize these elements like this. Last one is reinforcement learning. It is a branch of machine learning recently started to get a lot of attention after Google DeepMind successfully applied to learning to play Atari games. In this case, an agent is nothing but someone who interacts with the environment, who communicates with the environment, who perceives something, who produces something, receives information with its environment, and learn to choose actions that will maximize some reward. I think it may be positive or negative. For example, a neural network that looks at video game screen and outputs game actions in order to maximize its score can be trained via reinforcement learning. Currently, reinforcement learning is mostly a research area and has not been had significant practical success beyond games. In time, we expect to see reinforcement learning takes over an increasingly large range of real-world applications, self-driving cars, robotics, resource management, education, and so forth. Say this, we have input raw data, but the final outcome would be output. Here, there is an agent. Agent interact with the environment. Agent may receive something from the environment, produces something onto the environment. There is a best action. Whenever best action executed, you will get a reward. For that, you need to perform a selection of a good algorithm. When you select a good algorithm, it produces correct outcome, otherwise a negative. That's why I told you it may produce either positive or negative. This is a reinforcement learning. This is one point. Next one. In this case, we have one more component that is in the form of deep learning component. That is, in the case of deep learning component, we have a concept. The questions may be in the terms of machine learning components too. Sometimes they may ask you questions from machine learning. For example, here we have some set of questions. What are the advantages of self-learning? What are the advantages of supervised learning? What are the advantages and disadvantages of unsupervised learning, etc. And you all know clustering. What is meant by clustering? How clustering activities executes. Say this. Here we have clustering. We have k-means algorithm, k-medoids algorithm, db-scan algorithm, agglomerative hierarchical clustering algorithm, etc. Advantages of supervised learning may include unsupervised learning is well suited for complicated tasks when compared with the supervised learning, because unsupervised learning uses unlabeled data. Unsupervised learning is always preferable for various tasks, as getting the unlabeled data sets are easier as compared to the labeled data sets. But the disadvantages, they may be less accurate. And working with unsupervised learning is somewhat difficult for us when compared with labeled. Applications may be network analysis, recommendation systems, anomaly detections, singular value decomposition, etc. Whereas there's supervised learning advantages are considered. Supervised learning always work with the label data so we can have an exact idea about the classes of objects. So they may produce you highly accurate outcome. We can exactly predict exact output based upon prior experience because we have all our known labels. Disadvantages may include these are not suited for complicated problems. It may predict wrong output if the test data is different from the training data. See, any kind of machine learning algorithm always produces correct result whenever the test data or a training data is correct. Training data is correct. Previous experience is correct, then only we can have an outcome that is called as a machine learning. Disadvantages. These algorithms are not able to solve highly complicated tasks. They may predict wrong output. Lot of computational time may be required for trying the algorithm. Whereas semi-supervised algorithms are considered, semi-supervised, self-supervised are considered. They are simple and easy to understand the algorithm because it is a combination of both. It is highly efficient. It is used to solve the drawbacks of supervised and unsupervised learning problems. Disadvantages. Iteration results may not be stable. We cannot apply these algorithms to network level. Accuracy is somewhat low. Whereas reinforcement learning are considered, reinforcement learning is well suited for achieving long-term analysis or long-term results. It can be used for solving highly complex problems and we can easily model the things because no human interaction is needed. Reinforcement learning algorithms may not be preferable for simple problems. They require huge data and computations. It leads to sometimes overloading of state, which leads to problem. And then the next category is evaluating models. If you want to, once that a model is developed, we are going to produce an outcome, what you call evaluation. In order to evaluate any model, you require some common methods for evaluating machine learning models. Training of test split, how we are going to divide the data into partitions. Number one is in general, we have training set and test set. In many algorithms in future, we are going to discuss 50,000 samples are available. We are going to divide 25,000 samples or come under a training data. 25,000 training examples are come under a test data. Second one is cross-validation. Validation, whether the given input is right or not. We are using fold methodology, K-fold methodologies, or K1 fold methodologies, or iterative methodologies. Cross-validation. And there is a confusion matrix which can be used to evaluate the performance of classification model. A receiver operating characteristic curve ROC. It can be used for summarizing the performance of binary classification model. MAE, mean absolute error, and root mean squared error, which can be used to evaluate regression models. Precision recall curve, which can be used to evaluate classification model. And then the last topic related to this component, underfitting of training data. There are three categories of elements. Number one, exact fit, underfit, and overfit. See, the process is going to be executed in the terms of relationship between input variable and output variables. We are going to fit whether exactly data is connected with the training data to test data. There is no error at all. There is no overfit. There is no underfit. In order to overcome these fitting problems, we are going to have a maximizing of training time, enhances complexity of the model, add more features to the data, reduce regular parameter, increasing of training model, overfitting. That means whenever the curve exists, if the curve is the test data, and training data, both are exactly matched. We can say that exact fit. More or less, that is called as underfit. Overfitting refers to a machine learning model trained with a massive amounts of data that negatively affects its performance. Whereas underfit is concerned, it is a statistical model or a machine learning model that is said to have underfitting when it cannot capture underlying kinds of data. That is, it only performs well on training data, but performs poorly on testing data. So what are the reasons for underfitting? It may have inductive elements in the terms of a biasing, low variance, size of data training data set is not enough, the model is too simple, training data is not clean and also contain noise in it. So what are the techniques for reducing underfitting? We are going to increase model complexity, increase the number of features, remove the noisy from the data, increase number of stages, something. So underfitting exactly the test data, training data, maybe exactly matched is said to be exact fit or appropriate fitting. Too simple to explain the variance, what you call underfitting. Force fitting or too good to be true is said to be underfitting. This is the information related with machine learning models, evaluation methodologies, evaluation methodologies, and also approaches for underfitting, overfitting, or exact fitting. That's all.